Armed forces worldwide are getting more advanced day by day, but do you know who has the strongest navy in the world, or the largest navy in the world? Or what about the most advanced aircraft carrier in the world? Make sure you stick to the video to the very end, as we'll be answering these questions along with a few secret facts about the most advanced aircraft carrier. If you haven't already guessed by now, we are speaking about the Gerald R. Ford-class aircraft carrier. So without any further delay, let's get to know more about this aircraft carrier and its wide range of stunning capabilities on the battlefield. Kindly note that the information provided in this video is for educational purposes only. The Gerald R. Ford class is a futuristic aircraft carrier for the US Navy. Do not be surprised that the world's biggest aircraft carrier title belongs to the US Navy's Gerald R. Ford class air carrier. It is the first of its class of aircraft carriers to offer significant performance upgrades as a replacement for the Enterprise and Nimitz classes. The Gerald R. Ford class is designed to optimize the carrier air wing striking power. The ship's systems and configurations are optimized to maximize attached strike aircraft sortie generation rate, or SGR for short, resulting in a 33% increase in SGR over the Nimitz class. With its embarked carrier air wing, the aircraft carrier is a key asset for maintaining maritime superiority across various oceans. History has time and again proved the significant benefits of having the capability to bring a decisive air force to bear from the sea. The aircraft carrier, along with the ships and accompanying carrier strike group, is capable of carrying out missions ranging from large-scale combat operations to deterrent to humanitarian relief. Aircraft carriers are adaptive and flexible, and because of their size and weight, they can generate a high number of sorties to carry the payloads required to achieve multiple desired results in support of the national military objectives. The Ford-class aircraft carrier will be the most modern ship on the sea, ensuring that the Navy remains a ready and resilient force for the future. It will be built on the legacy of today's Nimitz-class aircraft carriers, as well as the investments the US Navy has made since World War II. Back in January 2007, US Navy stated that the next class would be known as the Gerald R. Ford class. The USS Gerald R. Ford, commonly known as CVN-78, was the first ship in the class to be delivered to the US Navy in May 2017 and commissioned in July 2017. Nimitz-class carriers has served as first responders in crises and conflicts for more than 40 years. The delivery of the CVN-77 in 2009 demonstrated the feasibility of Nimitz-class carriers' early 1960s design. These ships have served the nation well and will continue to do so in the decades ahead. When Gerald R. Ford CVN-78 is commissioned, Ford-class ships will begin to replace Nimitz-class ships. While the basic mission of the aircraft carrier will remain the same, Ford-class ships will provide increased lethality, survivability, and joint interoperability, as well as unrivaled versatility and compatibility with ongoing joint force transformation, all at a lower operating and maintenance cost to taxpayers. Ford will also be able to recover and launch numerous short takeoff and vertical landing aircrafts flown by the US Marine Corps, adding to its versatility. Finally, the ship's design margins will allow future manned and unmanned aircrafts to be integrated with minimal ship modifications. The island on CVN-78 is smaller and further rear than on prior carriers, allowing the ship and air wing to launch more aircraft sorties per day by providing an additional area for flight deck operations and aircraft maintenance. One other crazy feature is that the Ford class combines technological innovations that make the carrier more capable and efficient, while also allowing it to implement future technological advancements with reasonable simplicity. With expanded capabilities and lower total ownership cost, for example, through workforce reductions and innovations like higher nuclear power plant electrical production, fiber optic networks, improved corrosion control, and the use of innovative lightweight materials. Improvements in the hull design, firefighting systems, and weapon stowage are all a part of its improved survivability. The Raytheon Enhanced Sea Sparrow missile, which defends against high-speed, highly maneuverable anti-ship missiles, will be used on the Gerald R. Ford class weapons. The rolling airframe missile from Raytheon and Ramses is the close-in weapon system. Legacy steamed power systems have been replaced with electric drive components on the CVN-78. With 3 times the capacity of any prior carrier in terms of power generation, the ship is perfect for future upgrades with new and developing technologies during the course of its 50-year service life. The carrier will be able to transport up to 90 aircrafts, including the F-35 Joint Strike Fighter, FA-18EF Super Hornet, E-2D Advanced Hawkeye, EA-18G Growler Electronic Attack Aircraft, MH-60RS helicopters, and unmanned air and combat vehicles. The need for a greater sortie rate of 160 sorties per day surges to 220 sorties per day in times of crisis and severe air warfare activity, which demanded modifications to the flight deck design. The flight deck now has a smaller island, and there are 3 deck edge elevators rather than 4. Deck extensions also increase the aircraft parking areas. Furthermore, the flow of weapons to the aircraft stops on the flight deck was improved to suit the greater sortie speeds when we looked into the aircraft weapon loading. The ship carries fighter aircraft missiles and cannon rounds, strike aircraft bombs and air-to-surface missiles, and anti-submarine warfare aircraft torpedoes, as well as depth charges. The advanced weapons elevators, which offer quicker transportation of ammunition from magazines to aircraft, provide improved weapons and material handling. Weapons elevators transport weapon systems from magazines to weapons handling and assembly spaces on the 0-2 level deck, which is below the flight deck. And express weapon elevators transport weapon systems from the handling and assembly areas to the flight deck. A linear electromagnetic accelerator motor is used in the Electromagnetic Aircraft Launch System, also known as EMALS. At the Naval Air Systems Command Lakehurst Test Center in New Jersey, electromagnetic aircraft launch system demonstrators were put to the test. EMALS technology has the ability to enable better aircraft acceleration control, resulting in lower stress levels in aircraft and pilots, as well as a slower launch speed for unmanned air vehicles and a larger wind over deck speed window for the launch process. General Atomics was granted the contract to create an upgraded turboelectric arrestor gear. The synthetic arrestor cable is controlled by an electromagnetic motor, which reduces maximum stresses in the cable and the peak load on the arrestor hook in the aeroplane fuselage. With the new technology, a 100,000-pound object may be accelerated to 125 miles per hour in less than 300 feet. Crew workload and watch standing should be reduced as a result of new technologies and ship design elements. The Gerald R. Ford is the first aircraft carrier to be built entirely of electric utilities, nullifying the need for steam service lines, lowering maintenance costs, and increasing corrosion control. The upgraded A-1B reactor, electromagnetic aircraft launch system, advanced arresting gear, and dual-band radar all provide increased capability while requiring less personnel. The ship's systems and configurations are optimized to maximize attached strike aircraft sortie generation rate, resulting in a 33% increase in SGR over the Nimitz class. During the ship's 50-year service life, the ship's configuration and electrical generating plant are designed to accept future technologies, including direct energy weapons. Raytheon was contracted to furnish a version of the dual-band radar, or DBR for short, developed for the Zumwalt-class destroyer for installation on the Gerald R. Ford when it came to sensors. DBR is a phased array that combines X-band and S-band phased arrays. The Advanced Arresting Gear system, which is a follow-on to the Nimitz-class Mark VII system, allows Ford-class ships to recover both present and future carrier-based tailhook equipped aircrafts. AAG enables the recovery of a wider variety of aircrafts and minimizes the fatigue impact load on recovered platforms because of its increased control. Built-in test and diagnostic technologies are included in the AAG's design. If you enjoyed this video, please check out our other videos.